Okay, so for this lesson 1.5, we're going to be exploring angle pairs. So let me get out my pen. All right, so vertical angles, we're going to start with that. Vertical angles are going to be two angles whose sides are opposite rays. Two angles whose sides are opposite rays. So that's kind of like our formal definition. But if we were to kind of think about it maybe a little bit more informally, what that basically means is this: angles that are across from each other or directly across from each other. So like here I have two straight lines. You can see here two straight lines that intersect. And so like angle 1 and angle 2 would be vertical angles. They're directly across from each other and they're formed by opposite rays. So like for example, this ray is going out this way. Whoops. This ray is going out this way and this ray is going out that way. Let me use a different color actually. That might make it a little bit more easy to see. Okay, so like for example, so one ray is going out this way, and its opposite ray is going out that way. Whereas over here, this ray is going out that way, and this ray is going out that way. So opposite rays are forming angle 1 and angle 2. So we want to say that vertical angles are congruent. What that means here is angle 1 is going to be congruent to angle 2. And we can also say that angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4. Okay? You can see they're right across from each other. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So if I were to say that the measure of angle 1 is 65 degrees, I could also say that the measure of angle 2 is 65 degrees. Likewise, if I said, for example, that the angle 3's measure was, 135, then I would know that angle 4's measure is also, is 135. Okay, so 135 and 135. Now, on this page, a linear pair. So a linear pair is going to be two angles whose sides are adjacent, or which are two angles which are adjacent to each other, and add up to 180 degrees. And say add up to 180 degrees. So for example, here's angle 1. Sensitive pencil. So angle 1. There's angle 1, and here's angle 2. Now they're right next to each other, so it satisfies that requirement of a linear pair. And it's also on this straight line. So because on that straight line, I know it's 180 degrees total in a straight line. So angle 1 plus angle 2 is going to equal 180 degrees. And that's the angle addition postulate, right? The whole angle together, this whole thing from here to there is 180 degrees. So angle 1 plus angle 2 has to equal 180 degrees. And because they're next to each other, that means that it is considered a linear pair. Complementary angles are going to be two angles that add up to 90 degrees. So two angles that add up to 90 degrees. So in this example, let's pretend angle 1 was 45 degrees. Let's pretend angle 2 was 45 degrees. These guys would be complementary because 45 plus 45 is 90. Now they don't always have to be right next to each other. For example, maybe I have an angle like this that's 60 degrees. Maybe I have another angle that's 30 degrees. These two guys would be complementary because 60 plus 30 is 90. So any two angles that add up to 90, whether or not they're adjacent, are going to be considered complementary angles. Now each angle is called the complement of the other. So for example, the complement of 70 would be 20. The complement of 40 would be 50. Okay? So supplementary angles, like complementary angles, are going to be two angles, but instead of being added up to 90, they're going to add up to 180. So two angles that add up to 180 degrees. Okay? So in this example, let me scroll down just a bit. In the example here, so two angles that add up to 180, angle 3 and angle 4, because they're on this straight line here, I know that angle 3 plus angle 4 equals 180. So I know that angle 3 plus angle 4 is equal to 180, so they're supplementary. This diagram also happens to show a linear pair because not only do they add up to 180, but they're also supplementary. So like complementary angles, they don't have to be right next to each other. Maybe I have an angle like this that's 150 degrees, and maybe I have another smaller angle like this that's 30 degrees. And so these two angles here would be supplementary because they both add up to 180. So if they're next to each other and add up to 180, they're not only considered supplementary, but they're also considered a linear pair. But they can also be supplementary but not adjacent, like in this example here, and so they're just supplementary. Each angle is called the supplement of the other. So let's take a look at some examples here. So are 2 and 3 a linear pair? So if I'm looking at this here and thinking, are 2 and 3 a linear pair? Well, 2 and 3 are adjacent, so it satisfies that first requirement, because remember, for a linear pair, there has to be linear pair, two requirements. One, adjacent, and two, supplementary. Now, if I look at these 2 and 3, they are adjacent, satisfies that first requirement, but the second requirement, but they're not supplementary because this is not a straight line. So going from here, I'm going up, 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 it would have to keep going that direction, which it does not. It kind of juts out to the left. So they're not supplementary, so they are not a linear pair because it doesn't satisfy both of these requirements. Now, are 3 and 4 a linear pair? 3 and 4, they are. Here's our straight line, and they're adjacent, so yes. Are 1 and 3 vertical angles? So they look awfully close. In fact, let me erase the other markings that I kind of, so not to confuse you. Let's erase what I put around here. And sorry, let's try to, I don't know why that's, there we go. Okay, so coming back here. So if I look at 1 and 3, again, this line is supposed to kind of come up like this. Oops. Up like that. But it doesn't, right? It kind of juts out to the left. So this line here is not a straight line. So therefore, 1 and 3 are not formed by opposite rays. Okay? So their sides here, like this is an opposite ray with this, but here's one ray, but this over here out to the left is not an opposite ray. Okay? So 1 and 3 are not vertical angles. They're not kind of like directly across from each other. 2 and 4 is the same issue, right? So we have one side here of opposite rays, but this is not an opposite ray coming from here out and out to the left. So this would be a no. So 1 and 3 are vertical angles, no, and 2 and 4 are not vertical angles. Are 1 and 2 supplementary? So 1 and 2 are supplementary because it's on a straight line. So they have to add up to 180. And 1 and 4 are right next to each other. Here's 1, here's 4. So yes, they are adjacent angles. Now, finding the value of x. Well, because I can see that here's a straight line, I know that there's a total of 180 degrees, so I know they're supplementary. So I just add them together and set them equal to 180 in order to solve for x. 75 minus 5 is 70, plus 2x equals 180. Subtract 70 from both sides, divide by 2, and x equals 55. Okay, so the key here is just knowing that two angles that are on a straight line here, like 75 and 2x minus 5, add them up and set them equal to 180. Down here, I have to know the definition of vertical angles. So I know that here's two angles that are across from each other, okay, and whose sides are opposite rays. Okay, so over here, I have a ray going out that way, and a ray going out that way. There's some opposite rays. Ray going out that way, and a ray going out that way. So again, opposite rays. So I know they're vertical angles, so I can go ahead and I can set them equal to each other because vertical angles are always congruent. So 2y plus 10 equals y plus 60. Subtract y, and y plus 10 equals 60. Subtract 10, and y equals 50. Okay. Now, practice number 4 is a little bit trickier. First, to solve for x. Well, solving for x is exactly the same thing that I did up here in practice number 3. Okay, I'm going to set 3x plus 20 equal to 5x minus 50 because they're vertical angles. So 3x plus 20 equals 5x minus 50. So subtract 3x from both sides. And I have 20 equals 2x minus 50. Add 50 to both sides, 70 equals 2x. And so x equals 35 after you divide. Okay, so that's the first part. And that part is not too bad. But now I have to know how to figure out what this y is. Well, I'm going to plug the 35 in here. So where 3x plus 20, I'm going to plug it in because I want to find the actual measure of this angle. Well, that's going to be 3 times 35 plus 20. Well, 3 times 35 is 105. 105 plus 20 is 125. So I know this actual measurement is 125. And I've got this straight line here. So I know that total is going to add up to 180. So it's like y plus 125 equals 180. You just subtract 125 from both sides, and y is going to equal 55. So x equals 35, but y equals 55. Okay? So it's really important is that this whole angle is not equal to 35, just x is 35. So you have to plug it in to get the actual measurement of just the 3x plus 20 angle. Now over here it says given a and b are supplementary. So we have to know what the word supplementary means. Well, it means adds up to 180. So I can just say 12x plus 1 plus x plus 10 has to equal 180. Well, 12x and x makes 13x. 1 and 10 makes 11. Subtract 11. And divide, and x equals 13. So if x equals 13, well, that's great, but now I need to find the measure of each angle. So I'm going to take this 13, and I'm going to plug it in up there, and I'm going to plug it in over there. So the measure of angle A, measure of angle A is 12 times 13 plus 1, which equals 156 plus 1 equals 157. And the measure of angle B is going to be 13 plus 10, which is 23. So I've got my measure of angle A and angle B right there, 157 and 23. And I can check it to make sure they're supplementary because 157 plus 23 is 180. So you can see most of these problems are very similar. So they're just asking you kind of in different ways. So like over here, they're saying supplementary, so you have to know that what supplementary means in order to set your equation up right. Over in practice 4, you have to see that 3x plus 20 and 5x minus 50 are vertical angles, so you know to set them equal to each other. Same thing up here. You have to see that they're vertical angles, so you set them equal to each other. Here you have to see they're on a straight line, so they're supplementary. So as long as you so sometimes they'll use a diagram, and sometimes they'll just go ahead and just tell you that they're supplementary, and you have to know the vocabulary. But they're all generally the same kind of question. Okay, so here's another vocabulary issue. Complement of 21. Well, I can just do 90 minus 21, which I believe is 69. And then I can do the same thing over here. The supplement of 21 is going to be 159 because I'm doing 180 minus 21. 159. So what that kind of looks like, maybe I have an angle like this that's 21 degrees. And then for the complement, I have another angle that is going to make it a right angle. Oops, sorry. Let's try to. Okay, so I have a right angle. So if that's 21 and it's a right angle, this has to be 69. Now over here, maybe I have a straight line that looks like that, and maybe that this is 21 over here. So what does this have to be? Well, it has to be, it's a straight line, so this has to be 159. So that's a good way that you can kind of figure out what the complement is and the supplement is. Draw a right angle and figure out what you're missing, or draw a straight line and figure out what you're missing. Now, an angle bisector is going to be a ray that divides an angle into two equal or two congruent angles. Divides an angle into two congruent. Oops, trying to write quickly. Okay, so a ray that divides an angle to two congruent angles. So AY here, ray AY. I'll put a little ray there. I think got marked out. But ray AY is the angle bisector of angle X Okay, so that means that angle XAY and angle ZAY are congruent. Okay, so in the figure above, if XAZ is 112, in other words, this whole thing is 112, what are each one? Well, that's pretty easy. If I know that measure, if I know the measure of angle XAY plus the measure of angle ZAY is going to equal the whole thing, which is going to be the measure of angle XAZ. Okay? Well, I don't know what this measure is, XAY, but I know it's the same as ZAY. So if I give that X, I have to give this one X. Okay? And then this here, XAZ, they tell me is 112. Well, X plus X is 2X, and 112 stays, and so divide by 2, and you would get 56. So X equals 56. And so, of course, if XAY, measure of angle XAY is 56, then of course the measure of angle ZAY is also 56. An easier way, or maybe a more straightforward way of explaining that, is just if the whole thing is 112 and each of this part, and this part are the same, just divide by 2, which is exactly what we did. 112 divided by 2 is 56. So that's kind of an easier way of thinking about it rather than setting it up algebraically. Okay, this here is probably the best way of solving for it, but if you think about it pretty simply, it's this whole thing, it's being cut in half, so just divide this whole thing by 2. Now they're telling us find XAZ if each one is this 4x minus 16 and the other one is 2x plus 6. Well, I already know that AY is an angle bisector. So if it's an angle bisector, like I said, this guy, this guy over here and this guy over here are going to be the same. So I'll just set them equal to each other. So 4x minus 16 is going to equal 2x plus 6. So now I've set them equal to each other. I'm solving for x. Well, 4x minus, let's subtract 2x from both sides. Now I'm solving for x because if I can solve for x, I can plug it back in to this and this, and then I'll have the measure of each one. And with the measure of each one, I can add them together, and that will give me the entire thing. So I have 2x minus 16 equals 6. Add 16 to both sides, and 2x equals 22. And so x equals 11. So, having done that, I'm going to plug it into XAY. So the measure of angle XAY is going to be 4 times 11 minus 16. 44 minus 16, which is going to be 28, I believe, which means that the measure of ZAY also is supposed to be 28. So let's make sure that's true. 2 times 11 plus 6. Well, 2 times 11 is 22. 22 plus 6 is 28. So we're good. So ZAY is 28 and XAY is 28. So the entire thing is going to be 56. So therefore the measure of angle XAZ, or the whole thing, is 28 plus 28, which is 56. And this came from adding XAY and ZAY. 28 plus 28 gives us our whole number of 56 for XAZ. Okay? So there's some different angle pairs that are really important. Supplementary angles, complementary angles, vertical angles, and linear pairs. Those are kind of a lot of the more important angle pairs that we'll see throughout not only this unit, but also in geometry throughout the entire year.